As we continue talking about right triangles, we are going to talk about trigonometry, which is nothing more than the measures of a triangle. And we're going to talk about the different trigonometric ratios. And in those ratios, we'll learn about sine, cosine, and tangent. And of course, their inverse sine, inverse cosine, inverse tangent. And then solving for these values around the right triangle. Which will give us the ability to, it's an extension of the Pythagorean theorem given the side measurements. And so we want to be able to, not an extension of the Pythagorean theorem, but it allows us to discover lengths, calculate lengths measurements with only one side and possibly an angle. So we want to solve problems using trigonometric ratios for acute triangles. Of course, and then, or the acute angles, and then solve problems by using the inverse trig ratios for acute angles. So as we look at this, we want to talk about the ratios. And given a right triangle, let's see here, if triangle ABC is a right triangle, then the sine of each acute angle of ABC is the ratio of the length of the leg of the opposite that the angle of the length of the hypotenuse, or that to the length of the hypotenuse. So talking about the sine ratio of angle A is going to be the opposite over the hypotenuse. So it would be the opposite side over the hypotenuse. So the ratios are all dependent on which angles we are talking about. For example, the sine of angle A is the opposite over the hypotenuse, which would be A over C, the sides of A over C, or the sine of angle B would be the opposite over the hypotenuse. So its opposite is little b over C, the hypotenuse. So these ratios will depend on which angle we are looking from, perspective we are looking from. So you have the sine, which is going to be, the sine of some angle measurement is going to be the opposite side over the hypotenuse. The cosine of some angle measurement, is going to be the adjacent side over the, over the hypotenuse. So dealing with the adjacent side, so if we look at B, the adjacent side to angle B is going to be side A. So the cosine of angle B is going to be A over C, which is the adjacent side over the hypotenuse. So thinking about from angles B perspective, this is my adjacent side, this is my opposite side of angle B, and then the hypotenuse is always the side across from the right angle. And then the third ratio that we're really going to get into here is going to be tangent. So tangent is going to be talking about, using B as an example again, anytime we have the tangent of some angle is going to be equal to the opposite side over the adjacent side. So the tangent of angle B is going to be B over A. The tangent of angle A would be A over B. So just depends on which one of the angle measurements, which one of the angles we are looking at, to which side will be considered the adjacent, which side will be considered the opposite. And here for memorizing the ratios, SOHCAHTOA. That's what the common practice of this mnemonic is. This stands for the SO is sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. So SOHCAHTOA. So there you go. You have SOHCAHTOA. SOHCAHTOA to help you keep the ratio sides in order, keeping perspective of those. So as we talk about the different sides, what is that going to, right now we have gotten values for this. So it says find the trigonometric ratios for sine J, cosine J, tangent J. All right, so when we look here, sine of J is going to be the opposite side over the hypotenuse, so that would be 5 over 13. Putting that into the calculator, we can get an approximate. The cosine of j would be the adjacent over the hypotenuse, 12 over 13. The tangent of j would be the opposite over the hypotenuse. So, I'm sorry, the opposite over the adjacent, so 12 over 5 over 12. And then looking here now, the sine now of k is going to be the opposite of it, which is 12 over 13. The cosine of k is going to be 5 over 13, the adjacent over the hypotenuse. And then the tangent of k is going to be the opposite over the hypotenuse, because this side is opposite of angle k, this is adjacent to it. So there is being able to come up with these ratios. Now, if you'll notice, the sine of the acute angles here, the sine of k is the same as the cosine of j. And it would make sense because both of those angle measurements are, the sine of k is using the opposite over the hypotenuse, and then the cosine of j is using the adjacent over the hypotenuse. So they're actually using the same sides. So thinking about those are called complements because they have the same ratios. The sine of one acute angle is equal to the cosine of the other acute angle, and the same goes for the other angle. So just something we'll see more of in practice with that. So the right angles, okay, so the right angle, to use special right triangles to find the trigonometric ratios, it's the same. That if I have this angle measurement right here, angle 60, it says, it's telling us use the special right triangle to express the sine of 60. So again, the sine is equal to the opposite side over the hypotenuse, and this would be the opposite side, this would be the hypotenuse. So you would simply have the opposite side, x square root of 3 over 2x, and when you simplify that, remember your x divided by x becomes 1, so that is actually just the square root of 3 over 2. And when you put that into the calculator, you're going to get something about approximately 0.87 is the value, the ratio of those two sides. Okay, now looking at this to estimate using trigonometry, in this example, Matthias builds a ramp so his sister can access the back door of their house. Okay, so it looks like we're building a ramp. Looks like we have an angle measurement of 4. We have this length right here, this horizontal length of x. We have a height of y, and then it must be telling us that our ramp looks to be about 12 feet. So let's look here. The ramp, the 12-foot ramp to the house slopes upward from the ground at a 4-degree angle. What is the horizontal distance between the foot of the ramp and the house? So this distance, x. What is the height of the ramp? The height is y. And then it says, what are we looking at now? If I were to maybe express this, draw this a little bit easier for me to see. Let's obviously not draw on a scale, but if that's my 90 degree, this is 4 degrees, this is y, this is x. Looking from angle A, if I'm trying to find y, that is my opposite side, x is my adjacent side, and this is my hypotenuse because it is across from the right angle. So that allows me to think, hey, when I'm trying to find y, I'm going to need to use something that uses the opposite. When I want to find x, I need to use something that uses the adjacent. So the cosine of A, the cosine is going to be the adjacent over the hypotenuse. And they did tell me my hypotenuse is 12 feet. So the cosine of angle A is equal to the adjacent over the hypotenuse. The cosine of 4 degrees is equal to x, the adjacent x over 12, the hypotenuse. And then we go ahead, and here they said, let's multiply both sides by 12 so we can get x by itself. And then x is going to be equal to, when you plug into the calculator, 12 times the cosine of 4 degrees is going to be approximately 11.97. So when I go to put that into the calculator, this is sort of, things we need to make sure we understand. I went ahead and typed in 12 cosine of 4 degrees, and here's my cosine. So I just used 12 cosine and in the parentheses put a 4 in there. The first time I did it, my answer is incorrect, because you can see here the first time I did it, I was in radian mode, and you want to make sure that you are in degree mode. So I went ahead and changed the mode to degree mode because we're talking about the degrees of a triangle. So now I have 11.97, so that is making sure you're always in degree mode when dealing with these trig ratios. So just showing you that. So there we go, we're able to do that, come up with this value, and we just said that x is 11.97 approximately. So going on to the next problem, find the height. Well, we said the height was, again, that was y, and we had 12, we had angle A, we had 4 degrees. So it would have been the sine, because this was the opposite over the hypotenuse. So there you go, we would take the sine of 4 degrees is going to be equal to the opposite, which was y over the hypotenuse. Multiply both sides by 12, and we end up with 12 times the sine of 4 degrees is approximately 0.84, so a little bit less than a foot, okay? And then that's how we are able to calculate that information. Let's see here, so as we continue on, continuing on with these ratios, we're going to talk now about the inverse ratios. The inverse ratios, the expression sine of inverse, this is my inverse sine, is read the inverse sine of x, the inverse sine of x, and is interpreted as the angle with sine x. So be careful not to confuse that notation with a negative exponent. It's not a negative exponent, it is indicating the inverse of sine x. So here, this would be a negative exponent writing 1 over sine x. That is not what that is intended to indicate. So making sure that we understand that. There's a difference between the inverse function of sine and then, the negative exponent. So looking here, the ratios remain the same. So when I'm dealing with sine, it is still going to be the opposite over the hypotenuse. Cosine is still going to be the adjacent over the hypotenuse, and tangent is going to be the opposite over the adjacent, so katoa. But now we are using those side ratios to calculate the angle measurement. So here, if sine A is equal to x, then we know the inverse sine is equal to the measurement of x. So what we're looking at is we can use these ratios to come up with the angle measurement. The sine is going to be the inverse sine, inverse cosine, inverse tangent are going to be right here above the sine, cosine, and tangent right there. So sine inverse sine. So that's where my buttons are at for my calculator. So here it says use the calculator to find the measure of angle A. Well, angle A, so I would use that, let's see here, I have, according to angle A, this would be the opposite side, this would be the hypotenuse, this would be the adjacent side. So using the, not sine, but the cosine, the inverse cosine of 3 over 15, the adjacent over the hypotenuse, is going to end up giving me something along the lines of, so here I am looking for the inverse cosine of 3 divided by 15 is going to give me roughly 78.5. The 6 rounds the 4 up to 5. So approximately 78.5 degrees. I did not need to simplify this fraction. I just put it in just like that. The calculator is going to simplify that as it needs it. So no reason to waste that effort if I'm going to have to plug it into the calculator to get the answer anyway. So here, this first example, it says use the calculator to find the measurement of angle Z. Take a moment, do it on your own. and then I will go ahead and work on it. So the measurement of angle Z, when I'm looking here, this would be my opposite side, this would be my adjacent side, and this would be my hypotenuse in reference to angle Z, right? Opposite, adjacent because it's next to it, and then over here the hypotenuse because it is across from the right angle. So the measurement of angle Z should look something along the lines of, again, it would be the cosine is equal to the adjacent over the hypotenuse. So that would be the inverse cosine of the adjacent, which is 10 over 14, and that should equal. So using the calculator, 44.41, and then the 1 does not round up, it would just stay 4, so approximately 44.4 degrees. So using my ratios to come up with the angle measurements now. Let's see here, solving for a right triangle. Okay, solve the right triangle, round the sides and angle measurements to the nearest tenth. Let's see here, when I'm looking at angle R, this would be my opposite side, this would be my hypotenuse, and this would be the adjacent side. So if I needed to find the angle measurements for R, I could use the sine of the opposite over the hypotenuse. So the inverse sine, sorry, because I'm looking for an angle measurement, it will be my inverse, inverse sine. So the inverse of the opposite over the hypotenuse is going to be equal to the measure of angle R. So the measure of angle R is, it is going to be approximately 41.8 once you round. It's 40.81, so it would round to 41.8. So the measurement is approximately 41.8 degrees. Now, if I know that it is 41.8 degrees, I know that these two angles together should be equal to 90 degrees. So that's all they did, is they said, I can go ahead and do that substitution and simplify. I can subtract 41.8 from both sides, and then I come up with probably 48.2 degrees. Would be my other angle T, right? Because that would be approximately 48.2 degrees, because together they should add up to 90. All right, so 48.2 degrees. Using the Pythagorean theorem now, you do have the side lengths necessary. You have two side lengths, so using that would be considered like A, B, C, and we could use the Pythagorean theorem to come up with those different values. So subtracting 6 squared from both sides, you get some value here. All right, so doing that substitution, substituting for ST, RT would be 6 squared and equals RS squared plus 6 squared equals 9 squared. Subtracting subtracting 6 squared from both sides, we end up with 45. So then we do the square root of both sides, right? Bam, bam. So RS is equal to the square root of 45 degrees, which is going to be approximately 6.7. Approximately 6.7, 6.708. So looking at the 10th would be 6.7. So we were able to come up with that using that information. Now, I would take a moment and try and work on this problem right here. You're trying to come up with the missing sides, so we are going to have to use the trigonometric ratios to come up with this side and this side, because we're going to have to use sine, cosine, or tangent, because we have one angle measurement and one side length. And then once you come up with that side length, you can do a bunch of different things here. So I'm going to try to do it without the Pythagorean theorem, and we'll see how that goes. But I would now stop, try it on your own, and then check your answer. All right, so I started with looking for the measurement of angle C. So I know that these two are going to be 90 degrees together, so I took 90, angle C is 90 minus angle B. 90 minus angle A, which came to 28 degrees. So this is 28 degrees. Now doing that, if I look from angle C perspective, right, this would be my opposite side, this would be my adjacent side, this would be my hypotenuse. So in order to find x, I would use the opposite over the hypotenuse, or sine. So the sine of 28 degrees is equal to the opposite over the hypotenuse, multiplied both sides by 10 to get rid of my denominator. So 10 over 10 simplifies to 1, so x is equal to 10 times the sine of 28 degrees, which when the calculator spits out the number, it is x is approximately 4.7. Now I could use the Pythagorean theorem now to calculate the following side, but a lot of my students, once we learn trig, they won't do that. So I know that y is the adjacent side, so I could use, again, the cosine of 28 degrees. So the adjacent over the hypotenuse is going to be y over 10. And then again, multiply both sides by 10. And then 10 cosine of 28 degrees is equal to y. That comes to approximately 8.8. 8.8. So I didn't need to use the Pythagorean theorem once I have found how to use trigonometry. So there you go. We have 4.7 approximately and 8.8. So that is using our trigonometric ratios to help us solve problems when we don't have enough information for other methods such as the Pythagorean theorem. So with that, hopefully this wasn't new to you. Hopefully you're familiar with it, but again, learning these ratios, don't worry about it being a fraction. The calculator's taking care of it for you because it is able to calculate that information for us. And now we'll see how it goes.